Assalamualaikum. In this episode, we go back to the basic concepts of electricity. 8 conceptual test questions will be discussed and explained, so just hang on till the end of this video. Watch and learn. Question number 1. When we say an appliance uses up electricity, we really are saying that option letter A, current disappears. Option letter B, the main power supply voltage is lowered. Option letter C, electrons are taken out of the circuit. And option letter D, electron kinetic energy is changed into heat. In physics, electricity here pertains to the electrical energy carried by the electric field in an electrical circuit that causes the free electrons' kinetic energy to be converted into heat. So that means the correct answer for question number 1 is option letter D. Electron kinetic energy is changed into heat. Question number 2. Of the following, the copper conductor that has the least resistance is letter A, thin, long, and hot. Option B, thick, short, and cool. Letter C, thick, long, and hot. And option D, thin, short, and cool. This is the equation that relates the resistance, denoted here by big R, with the conductor's length, cross-sectional area, and a constant denoted by the Greek letter rho, called the resistivity of the conducting material. Right? And this is conceptually, resistivity is just the opposite of electrical conductivity. And the resistance big R decreases, all right, with decreasing temperature. So temperature of the conducting material is another factor that may affect the resistance of the conductor, although it is not included in this equation, right? Also, we say that the lower the temperature of the conductor, the less is its kinetic energy, all right? In other words, uh, the average kinetic energy of the particles, all right, including the free electrons, is less. So that means there is a decrease in the collision of these free electrons with the atoms or ions in the material, right? So that makes our answer for question number 2 will be option letter B. That means the copper conductor would have the least resistance if it is thick, short, and cool. Question number 3. In the circuit diagram shown, the three bulbs have varying resistances. That means resistance number 1 is greater than resistance number 2, and it's also greater than resistance number 3, right? Question is, which bulb has the largest potential or voltage across it? Choices are letter A, bulb number 1, option letter B, bulb number 2, option letter C, bulb number 3, and option letter D, all the three bulbs, okay, have the same electric potential or voltage across them. All right. So when the resistors are connected in series, such as what is shown in this circuit diagram, all right, um, the current through each of them is the same or constant, regardless of their varying resistances. All right. So what? That's one uh, key concept in analyzing uh, a circuit that have resistors in series, right? Current is the same, right? Regardless of the amount of the resistances of the three bulbs. Also, we have this law, Ohm's law, okay, which can be expressed in terms of this equation. The voltage is just equal to the product of the current and the resistance, right? So, if the current capital I is constant, it is obvious that the voltage and the resistance are directly proportional, meaning uh, if the resistance is high, then it follows that the voltage across the resistor, or in this case across the bulb, will also be large. So, our answer therefore for this question is option letter A. It is bulb 1, okay, the bulb which has the largest resistance, okay, will also have the largest voltage across it or electric potential. Question number 4. Car batteries are rated in amp hours. This is a measure of their letter A, charge, option B, current, option C, EMF, or option D, power. Amp or ampere is actually a unit of current, and hours is a unit of time. So when current is multiplied by time, we get the amount of charge, big Q. So the correct answer therefore is option letter A, charge. Question number 5. Consider two copper wires. One has twice the length of the other, but is twice as thick. How do the resistivities of these two wires compare? Option letter A. Both wires have the same resistivity. Option letter B. The longer wire has twice the resistivity of the shorter wire. Option letter C. The longer wire has 4 times the resistivity of the shorter wire. And option D. None of the given answers. The correct answer is option letter A. Both wires have the same resistivity. Our explanation is still based on this equation. Resistance big R equals rho times the length divided by the cross-sectional area of the wire. Right? So in this equation, we said that the Greek letter rho represents the resistivity of the conductor, right? Which is a constant value for a specific metallic conductor, such as copper wire, whose value of rho is given here as 1.724 times 10 to the negative 8 ohm meter at a temperature 20 degrees Celsius. All right. In short, uh, depending also on the temperature, the higher the temperature, all right, the higher also is the value of the resistivity. All right. Just like the case of resistance. So in the question, um, which says that the same copper wire, all right, but with varying lengths and uh, cross-sectional areas or thickness, we say that at constant temperature, the resistivity rho is the same. Question number 6. If the resistance in a constant voltage circuit is doubled, the power dissipated by that circuit will, option letter A, increase by a factor of 2. Option letter B, increase by a factor of 4. Option letter C, decrease to 1/2 its original value. And option D, decrease to 1/4 its original value. The correct answer is option letter C. Electric power P can be expressed as the product of voltage and current, or P equals V times I. If the voltage is expressed in volt, right, and the current is in ampere, then the SI unit of power is volt ampere or watt. Now, for a series circuit, right, we can derive the power formula by substituting I times R for the voltage V. All right, so IR times I will have the power equals the square of the current I and multiplied by the resistance R. So that's for series. While for parallel, we can substitute V over R for the current I, right? But V over R will be multiplied by the voltage V. So we get the derived formula. P equals V squared over R. That's for parallel circuit. All right. You may notice that uh, in series circuit, if the current is constant, then the power is directly proportional to the resistance R. But in parallel circuit, right, if the voltage is constant, then the power is inversely proportional to the resistance. All right. Now, um, in this question, all right, um, the the voltage V should be constant. All right. So the formula for power that we have to use is this one. All right. That is for a parallel circuit, P is equal to V squared over R. All right. And again, if V is constant, okay, which what is assumed in the question, if the resistance big R is doubled, all right, with a constant voltage, then the power decreases by half of its original value. Question number 7. If the resistance in a circuit with constant current flowing is doubled, the power dissipated by the circuit will, option letter A, quadruple. Option letter B, double. Option letter C, decrease to one half its original. Option letter D, decrease to one fourth its original. So the correct answer in this question is option letter B. All right? The power dissipated by the circuit will double. This time, um, we have to use the equation, right, for series circuit. That is, power is equal to the square of the current multiplied by the resistance R. Right? Uh, why do we choose this formula? It is because the question pertains to having a constant current. Right? So it is this formula uh, for series circuit where we say that the current is constant. And so therefore, uh, if the resistance R is doubled, then the power P will also double because power is directly proportional to the resistance R. For our last question, number 8, you obtain a 100-watt light bulb and a 50-watt light bulb. Instead of connecting them in the normal way, you devise a circuit that places them in series across normal household voltage. Question: which statement is correct? Option A, both bulbs glow at the same reduced brightness. Option B, both bulbs glow at the same increased brightness. Option C, the 100-watt bulb is brighter than the 50-watt bulb. And option D, the 50-watt bulb is brighter than the 100-watt bulb. The correct answer to this question is option letter D. The 50-watt bulb is brighter than the 100-watt bulb. So, bulb 1 has a power rating or wattage rating of 100 watts. Okay, while bulb 2 has 50 watts. We assume that each bulb, when wired across the main outlet, will have a potential of 220 volts. This is the RMS voltage here in the Philippines. And to be able to compare their brightness, we need to know the respective resistances R1 and R2. All right. We use the formula power equals V squared over R. All right. This is the formula for power in a parallel connection. Right. So we use this formula P equals V squared over R to compute the resistance R of each bulb. Okay. For bulb 1, its resistance R1 is just equal to 220 volts squared, and that will be divided by its wattage of 100 watts. So doing our math, we will get the value of R1 equal to 484 ohms. Similarly, for the second bulb, all right, R2 is equal to 220 volts, that will be squared and then divided by 50 watts. All right, so simplifying, we get 968 ohms. As expected, the value of the resistance for bulb 2 is twice that of bulb 1, right? And as emphasized in the question, when these two bulbs are connected in series to each other, right, across the main voltage outlet, all right, since they are in series, all right, so we use the formula P is equal to I squared times R, where the current passing through each of these bulbs is constant. And that means if the current is constant, all right, the power is directly proportional to the resistance R, right? And this suggests that if the current is the same for both bulbs, then the bulb with the higher resistance will have the greater power dissipated. In short, all right, bulb 2 or the 50 watt bulb will be brighter than the 100 watt bulb, right? So that explains our answer to question number 8. And that concludes our tutorial for this topic. Till the next episode, mabuhay, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.